Hello, this is a module 4 investigation 2 about comparing linear and exponential behavior. When we examine situation with the varying quantities, we typically want to identify pairs of the quantities that are changing together, covary. When we identify such a pair, our next goal is understand how their value change together and if possible to identify patterns in the relationship. In other words, when studying covariant relationship, we want to identify what stays the same while the quantities change. So in a previous model, we closely examined the linear function. And then the linear function exists when the two quantity value change together with the constant rate of the change. And then such a relationship in two quantity value are free to vary, but they must do so in such a way that the ratio of the change of delta y over delta x is a constant. But not all covariant relationship exhibits a constant rate of the change. In this investigation, we will encounter example of different types of relationship and identify what remains the same as the two quantity covary. So for example, through the 1 through 5, exercise through 1 through 5, we use the following information. So when a piece of the new technology invented and sold, its value decrease over the time because it wears down and because even newer, better technology is developed to replace it. So suppose two electronic devices have the same resale value right now, and that their resale values are expected to change according to the following pattern. So there are two products. So one product is iTech device, and the second one is the dynamic system device. So the first one is gonna be the current sales value is 300, and the resale value is gonna be expected to decrease 30% per year for the next several years. And then product two is the Dyna Systems device. The current resale value is 300, same as the first one, but resale value is expected to decrease of $45 per year. So number one, find the expected resale value in dollars for both devices 1 year from now, and then describe how you determine each value. So first one is iTech device. It's gonna be the 30% off, which means negative 30% off, which means the price for the 1 year later is going to be the 70% still stays. So which is the same as 0.7, and then you can multiply 0.7 times to the original price, and then it will becomes the 210. And for the Dynast system device was $40 off. So in order to have $40 off means you just need to subtract 300 minus 45, and then becomes 255, and then that's the price. Okay, so the iTech device is gonna be the $90 off, and then for the Dyna System device is gonna be just the $45 off. Okay. All right. So without the performing additional calculation, predict which device will have the greater resale value 6 years from now on. So I need you to think about it. Okay. So think about which price is gonna be the greater after 6 years. Okay, and then in C we're gonna see which one will be actually the greater price, greater values. Okay, so the first table, it's about the iTech device, and the second one is about the Dynasystem device. Okay, so So delta T means the change in time, which is a year, and then the delta S is going to be the change as a sale price. So the it's going to be 1 year. So start with the 0 years. So how many years pass by from the next year is a 1 year, and then 1 to second year, so another 1 year, and 2 go to 3, another 1 year, and 3 to 4, another 1 year, 4 to 5, another 1 year, and then 5 to 6 is another 1 year. So we'll see how much will be in the 6 years. So it decreasing by the 30% up. So 300 times 30% up, which is a 0.7, will be 210. And then from the 210, which is a $90 off, which makes a 30% off. So another 30% off from the 210 is gonna be the $63 off, and becomes $147. Another 30% off from the 147, which makes $44.10, and becomes $102.90. Another 30% off from the 102.90, which becomes 30.87. And then subtract from the $120.90 becomes $72.03. Another 30% off from the $72.03 will be the $21.609. And then the subtract from the $72.03 becomes $50.0421. And then another 30% off from the $50,421 makes a negative 15.1263, and subtract that price from the $50,421, and then in 6 years it becomes $35.2947. Okay, now for the Dyna system, 0 to 1, 1 year pass, year changes 1 year, 2 to 3, 1 year change, 3 to 4, 1 year change, 4 to 5, 1 year change, 5 to 6, 1 year change. But each year it's going to be $40 off. So, okay, so start with the $340 off means 255, and another $45 off becomes 210, another $45 off 165, another $45 off 120, another $45 off 75, another $45 off, it becomes a 30. So you can compare to see. Now when you compare, which one has a greater value? Which is going to be iTech device has more values. Alright, let's look at the next page. Now, the table on the left demonstrates how the expected value, expected resale value, for the iTech device could vary with the elapsed time. What stays the same as these two quantities value changing together? So the percent change remains the same even though the difference in dollars does not stay the same. So in this time, the percent changes stay the same. Even though the difference of dollar is different, right? Okay. So because always 70% stay the same, right, of the previous price, but the dollars is amount is different. F. The table on the right demonstrates how the expected resale value for the Dyna Systems device varies with the elapsed time. What stays the same as the two quantity value change together? This time is the expected resale value changes as a constant rate, which was $45 per year. Okay, number 2. Define the function formula model the expected resale value in dollars for each device as a function of the number of the year from now t. So f of t is gonna be the start with the $300 and then stays 70% and then by years, okay? But the dynamic system is a linear, so we have to say you start with the 300 and subtract the $45 per year. So explain the what each part of the formula represented relative to context we are exploring. So as a iTech device, so it's a f functions. So 300 was the original price, and then the 0.7 was the expected value, after each year. It's going to be 70 over 100 times is larger than expected value 1 year previous. So each time t increases by the 1, expected the resale value in dollar is multiplied by 7 over 100. Okay. For the g function, 300 was the original price, but negative 45 will be the constant rate of the change. With respect to t. Okay, so interpret following using your function from the exercise 2. So I think I can skip that one. So f4, which is you can use the 4 for the f function by the, so after 4 year, what is the price of the items? But I don't need to do number 3. Okay, so let's go to number 4. So number 4, in exercise number 1, the table on the left has a column showing value of s equal to f of t, expected resale value for the iTech device in dollars, as well as the column showing value of the delta s. The change is the expected resale value for the iTech device in dollars. So what are the ratio of the consecutive entry in the column for s? So that is what is the value of the f of 1 over f of 0, and f of 2 over f of 1, f of 3 over f of 2. So f of 3 over f of 0. So everything about the f of t is gonna be the price of each year. Okay, year in the parentheses. Okay, so it's about ratio. So each ratio as evaluate to the 0.70. Okay, that stays all the time. If you divide by the previous year to divide this year. So how does your answer part A relate to the original problem context? In other words, then what do you this ratio tell you about the resale value for the iTech device? So which means expected value at any moment is 70 over 100 times as large as, which is 70% of the expected value 1 year previous. C. What are the ratio of the value delta s compared to the value of s the beginning of the each interval? So each ratio evaluate to the, so in this time is each ratio, which is the delta s, evaluate to negative 30. the 30%. Alright, how does your answer part C relate to the original problem context? In other words, what do this ratio tell you about the resale value of the iTech device? So, which means the change in the expected value over the course of 1 year is negative 30 over 100 times as large as the expected resale value at the beginning of that interval of the time. Alright, the following are graph of the function f and g model the expected resale value for each device over next 6 years. On each graph, we have plotted the point that correspond to the order pair. You should have a calculate exercise 1. So, yeah, so we got that 2 graph here by 30% off, and then $40 off for each year. So, yeah, I can see that those are the year passing by the prices coming out. Okay. And this is the same thing too, okay? And then to help the focus attend of the value of the S and N, expect the sale values of each device in dollars. Represent our previous table. So we have a drawn vertical line segment. Those length represent the value S and N respectively. Okay, so all right. So let's look at the next page. So when you look at the bar graph, you can see as first year price was this much, and the second year this much, and it's kind of decreasing, and then same as a decreasing. But this actually, if you connect them the top point together, it's going to be the linear, and this makes actually the exponential. So number 5, explain how you can see the graph, the fact that the expected value, the resale value of the iTech device at some moment is 70% of the expected resale value on 1 year earlier. So which means the how the length of the any segment on the graph of f representing the value of the function of the output for the input is always 77 over 100 times as large as the length of the previous segment. So I want to say that the functions of the value of the functions output for that input is always 70 over 100 times as large as the length of the previous segment. And then B, explain how we can see the graph of the fact that expected the resale value of the iTech device change to 30% each year. So the change in the output value from the 1 point in the time to on point to the time 1 year later is negative 30 over 100 times as large as the output values. So the change in the output value from 1 point in time to a 1 point 1 year later is negative 30 over 100 times as large as the output value at the beginning interval. Alright, C. Explain how we can see the graph of the only one of the two devices has expected resale value a change, a constant rate of the change with respect to the number of the elapsed years. So which is a graph, will be the graph of the G. So the graph of G demonstrate the relationship delta n equal to m times delta t for the constant m, which this time is negative 45. But the function f does not demonstrate the relationship equal to delta s equals to m equal to delta t for some constant m. Instead, the change in s depends on the value of s at the given time, and thus the delta s is not always the same number of the time as large as the delta t this time. Alrighty, let's look at the number 6. Suppose another piece of the technology, I take 2 device that has a current resale value of the 400, and that this value is expected to change by negative 50% per year. So that function h models is expected resale value in dollars t from now. So without the performing any calculation, plot the approximate the value of the in-order pair of the 1 equal to p of 1. Okay, so this time actually the price was 400, but each year gonna be the 50% up. So okay, let me put it this way. So it's gonna be the initial year $400, and each year so 50% off means that you still have 50% by year. So the h of 1 means 400 times 0.50, so which is 400 times 0.5 is it is 200, and then h of 2, which is 400.5 to the second year, so 400.5 to the second power, it is another 100. So h of 3, which is 400.5 to the third, I think it's a 50, but 400.5 to the third power, yes, it is a 50. And then fourth year, 400.5 to the fourth, so 400.5 to the fourth, which is 25. And h of 5 is 400 now, 0.5 to the fifth year, which is 12.5. And then sixth year, so 400.5 to the sixth, so 400.5 to the 6 is $6.25. And then you can plot them in. So 0 year was 400. And then second year was 200. First year was 200. And second year was 100. Third year was 50. And 12.5. And 6.25. Oh, hold on. 1 year, 200, 100, 50. Oh. Third year, 50. And then, yeah, 12.5. And then 625, right? So, yeah. So, you can connect them nicely as a curve. Yeah, this is it. Yeah, so graph is going to be like that. So explain how you, the letter B, explain how you were able to estimate the value of the order in pairs in par. So we need to explain the relationship between the percent change and the percent remains after t changed by 1 this time. Okay, so now there's another devices that we can think about it, and this time is original price was $500 and then decreased by 20%. So we need to plot the approximate points to there to find out, right? So in this time, J of t is starting from the 500, so 20% off, which means you have 80% still there for the time t, okay? And then you can figure it out. What is g of 0? J of 1, J of 2, J of 3, J of 4, J of 5, J of 6. Plug it into right there and then find out. So exponential function means two quantity change together such that the for equal changes one quantity values. The second quantity value have a constant percent change, then we say that the relationship is exponential functions. Okay, so that's all. All right, thank you for listening.